All right, so we're doing minimum flow, maximum cut sort of things, and so we're always wary of the idea of backflow happening, aren't we? So somewhere in this question, we're going to have some backflow to check out. Let's get on with part A. Cut 1, what is its capacity in liters per minute? Let's have a look. We've got this 15 and a 20 and a 25. They all look like they're going from source to sink. So we can just add all those up. 15 plus 20 plus 25 equals 60 liters per minute. I'm going to put my unit on there because I like to. Capital L for liter, always, because we're good scientists and engineers. And no backflow yet. Let's try the next one. This is a little bit trickier. It says we need to find, or we need to draw on the diagram, which is now to the left, not above, because I cut and pasted things, which has a capacity of 70 liters per minute, and I've got to label it clearly as cut 2. All right, so I want to get a bigger number. Now, just remember, if you've got 15 and 25, the two fives add up to make a 10, and we're aiming for 70. So we've got to make sure we cut 2 of them that have a 5 in them. So it's unlikely to include this because it's very hard to pair that with another 5. So we can rule out this 25 being involved. And we probably want to include the 40 because it's a nice big number, right? So I'm just going to go with a straight, nice little cut through the middle there. Now, if I look at this, I got 10, 10, backflow 10, so this one doesn't count. So it's only 20 so far, plus the 40, that only gives me 60. So it's not that cut straight through the middle there. All right, so learnt my lesson, not that one straight through the middle. But maybe if we go, instead of going through the middle here, we're going to bend it around like that, okay? So that other cut didn't work. Let's see what we've got going on here. We've got 10, 20, backflow 10, which doesn't count, plus 40, that is 70. I'm going to clean that up because I said to be very nice and do it neatly. So I'm going to do that neatly and do a dotted line like that and call it cut 2. And that does actually have a capacity of 70 liters per minute. Now, part C, determine the maximum flow in liters per minute from the source to the sink. So we knew that was coming, didn't we? Let's have a look at this. Now we've done what I call a source cut, and we know that's 60. So that's our best guess so far. But let's just do a little one around the sink, and we can find that that has a capacity of 45 because we've got 25 and 20 there. So that's fairly easy to do. So 45 is now our new champion. So we can just forget about cut 1 and it's 60, and we can forget about cut 2. All we've got to see is, can we improve on that? Are there any better cuts in there? Well, if you look in this, we want to probably avoid the 40 line. So is there a way to cut that wouldn't include the 40 line? Well, let's cut like this. Now, interestingly enough, we've got 10 and 20, but this one is backflow. This one going down is backflow, and this one is coming in. So this cut actually has a cut of 40 because we have double backflow, and we've managed to avoid this big 40 as well with that cut. So that cut has a capacity of 40, so we're going to write 40 liters per minute. That one was quite a tricky one, actually, I think.